In this lesson, we are going to learn some techniques to evaluate the limit of a function as x approaches a number. So our goal is evaluating the limit of some relatively complex functions as the independent variable approaches a number. In our previous lesson, we learned for some functions such as polynomials or rational functions, the limit of the function and the value of the function as x approaches a number are the same. For polynomial functions, it is always true. For rational functions, this statement is valid if the denominator as x approaches the number is not approaching 0. We had some properties of limit. Limit of addition of functions is addition of limits. Limit of subtraction is subtraction of limits. Limit of a constant is constant times the limit. By applying those properties, the limit of 3x2 plus x minus 1 is 13. Or we can say the value of polynomial f of x equals 3x2 plus x minus 1 at 2 is 13, therefore the limit is 13. So our first trial to find the limit of a function as x approaching a number is direct substitution. If we get a number, that number is the limit of the function. For example, limit of x3 plus x minus 4 over root x is 1 plus 1 minus 4 over 1, which is negative 2. Or limit of square root of x3 plus x2 as x approaches 1 is root 2, simply because square root of 1 to the power of 3 plus 1 to the power of 2 is root 2. In some cases, direct substitution fails. The technique that we use in these cases is called reducing the function. For example, to find the limit of 2x minus 1 over x plus 1 minus 1 over 2 divided by x2 plus x minus 2 as x approaches 1, we get 0 over 0. 0 over 0 is called indeterminate form. If you plug the number x equals 1 in the numerator, we get 0. The denominator, we get 0. It's just a symbol to show this is indeterminate. To find the limit, we simplify the fraction. Notice that if p at a equals 0, when p is a polynomial, then x minus a is a factor of p at x and the other way around. Factor theorem. When both the numerator and the denominator as x approaches a approaching 0, x minus a is the common factor. If we take the common denominator on the top of the function, we have 3x minus 3 over 2x plus 2 times x plus 1. And the denominator can be factored at x minus 1 times x plus 2. 3x minus 3 is 3 times x minus 1. We reduce the fraction by x minus 1, and our limit would be limit of 3 divided by 2 times x plus 1 over x plus 2. As x approaches 1, this limit is 1 over 4. Therefore, the given limit is 1 over 4. The key here is when we get 0 over 0, we reduce the fraction by x minus a. To do this, as we saw, we either use factor theorem or we rationalize if we deal with radicals. The other technique is called change of variable. Limit of cube root of x minus 1 over square root of x minus 1 as x approaches 1. If we rationalize both the numerator and the denominator of the given function, we have the limit equals to limit of square root of x plus 1 divided by cube root of x2 plus cube root of x plus 1 as x approaches 1. Notice that square root of x minus 1 times square root of x plus 1 is x minus 1. and cube root of x minus 1 times cube root of x2 plus cube root of x plus 1 is x minus 1. Difference of squares and difference of cubes. Therefore, the given limit is 2 over 3. Let's use change of variable and find the same limit. Notice that the common index between 3 and 2 is 6. We assume u is 6 root of x. Therefore, the limit can be written as u2 minus 1. If u is 6 root of x, cube root of x would be u2, divided by u3 minus 1 as u approaches 1. Again, notice that if 6 root of x is u, square root of x is u3. We factor both the numerator and the denominator. We cross u minus 1, and we find the limit, which is 2 over 3. As you see, we had two different methods, and the final answer are the same as we expected. One of them we used rationalizing, and the other one we used change of variable. Change of variable basically converts the function from irrational form to the rational form. Let's have a couple of examples. Example 1, limit of x2 minus 6x plus 5 divided by 2x2 minus x minus 1 as x approaches 1. Direct substitution fails because if we plug in 1 into the function, we get 0 on the top, we get 0 at the bottom, and the limit is 0 over 0, indeterminate form. We know x minus 1 is the common factor between the numerator and the denominator. We factor the numerator. The numerator x2 minus 6x plus 5 is x minus 1 times x minus 5. The denominator is x minus 1 times 2x plus 1. And if we reduce the fraction, the limit would be the same as limit of x minus 5 divided by 2x plus 1 as x approaches 1, which is negative 4 over 3. Example 2, limit of x4 minus 81 divided by x3 plus 27 as x approaches negative 3. The numerator is difference of squares, x2 minus 9 times x2 plus 9. The denominator is sum of cubes, x plus 3 times x2 minus 3x plus 9. We reduce the fraction by x plus 3. The limit would be the same as limit of x minus 3 times x2 plus 9 divided by x2 minus 3x plus 9 as x approaches negative 3, which is negative 4. We found negative 4 by direct substitution in the simplified form of the function. Example 3, find the limit of x over square root of x plus 4 minus square root of 4 minus x as x approaches 0. We rationalize the denominator by multiplying both the numerator and the denominator by the conjugate of the denominator. Conjugate of square root of 4 plus x plus square root of 4 minus x is square root of 4 plus x plus square root of 4 minus x. If we multiply the denominator, we get 4 plus x minus 4 minus x, which is 2x. We reduce the fraction. We simplify it by x. The limit would be the limit of square root of 4 plus x minus square root of 4 minus x over 2 as x approaches 0. If we plug in 0, we have 2 plus 2 divided by 2, which is 2. Therefore, the given limit is 2. Next example, limit of cube root of x plus 8 minus 2 divided by x. We assume cube root of x plus 8 is u. Then x would be u3 minus 8. The fraction can be written as u minus 2 over u3 minus 8 by this assumption. When x approaches 0, cube root of x plus 8 approaches cube root of 8, which is 2. To find the limit, we use the factoring and we factor the denominator, it would be u minus 2 times u2 plus 2u plus 4, and the limit would be the same as limit of 1 over u2 plus 2u plus 4, which is 1 over 12. Let's recap. To find the limit of a function, the first trial is always substitution method. If we find a number, that number is the limit. For polynomials and rational functions, usually direct substitution method is working. If direct substitution method fails and we have 0 over 0, as x approaches a, we reduce the fraction. In some cases, instead of rationalizing, we use change of variable. Thank you.